Hello students, today we will learn about one of the three major main engines in power plants, the steam turbine. We'll explore the historical development of steam turbines, their types and models, as well as their working principles. A steam turbine is a rotary engine that converts the thermal energy of steam into mechanical energy. For example, in thermal power plants, nuclear power plants, and geothermal power plants, steam turbines are most commonly used as prime movers. In thermal power plants, the exhaust steam or intermediate extraction steam from the steam turbine can also be used to meet the heating needs for production and daily life. Additionally, in thermal power plants, steam turbines can directly drive various pumps, fans, compressors, and ship propellers. In factories with residual heat and energy, various types of industrial steam turbines can be utilized to make thermal energy utilization reasonable and efficient. The invention of steam turbines has a history of over 100 years. In 1883, the Swedish engineer D. Lovell developed the first axial flow steam turbine. Around 1920, regenerative cycle steam turbines appeared. In 1925, the first reheat steam turbine was introduced. Since its inception, the development of steam turbines has been rapid. Its development characteristics are primarily that the power output of individual units is increasing, the steam parameters are high, the efficiency is high, and operational performance is excellent. Currently, the main manufacturers of steam turbines include General Electric Company in the United States, Westinghouse, ABB in Switzerland, Alstom in France, etc. In China, the major power equipment manufacturers are Harbin Turbine, Shanghai Turbine Works, Dongfang Turbine, Hangzhou Turbine, which specializes in industrial steam turbines, and Nanjing Turbine Generator, which focuses on gas turbines. The equipment and systems of steam turbines mainly include the turbine itself, the control and protection system. Auxiliary equipment includes condensers, extraction pumps or water rings, vacuum pumps, high and low pressure heaters, storage tanks, feed pumps, condensate pumps, circulating water pumps, and so on. The main system of a steam turbine include the main steam and reheat steam systems, the condensing system, the feed water regenerative system, and the oil system, among others. Now, let's take a look at the classification of steam turbines. First, according to the working principle, steam turbines can be classified into impulse turbines and reaction turbines. Impulse turbines are primarily composed of impulse stages, where steam mainly expands in the nozzle guide vanes, also known as stationary blades, with only a small amount of expansion occurring in the moving blades. In contrast, reaction turbines are mainly composed of reaction stages, where steam expands in both the stationary and the moving blades, and the degree of expansion is the same in both. The set referred to here is the basic working unit of a steam turbine, consisting of a series of nozzle guide vanes and a row of moving blades immediately following them. High-speed steam flows through the moving blades, and due to the change in the direction of the steam flow, it propels the impeller to rotate and perform work, converting the thermal energy of the steam into the mechanical energy of the impeller rotation. The steam undergoes two energy conversions within the turbine. One is a conversion of thermal energy to kinetic energy in the nozzles, and in the moving blades, the kinetic energy is then transferred into mechanical energy. The working principle of the impulse steam turbine is that the steam experiences a decrease in pressure and an increase in flow speed in the nozzles, converting thermal energy into kinetic energy. After entering the moving blades, the steam only changes its flow direction, and the impulse force causes the impeller to rotate, transforming the kinetic energy into rotational mechanical energy. The working principle of a reaction steam turbine involves steam expanding in nozzles, causing a decrease in pressure, and an increase in flow velocity, thereby converting thermal energy into kinetic energy. The steam then expands in the moving blade cascade, resulting a further drop in pressure and an increase in speed, with the steam's thermal energy being converted into kinetic energy. Second, according to their thermal characteristics, steam turbines can be classified into condensing steam turbines, back pressure steam turbines, regulating extraction steam turbines, intermediate reheat steam turbines. In a condensing steam turbine, the steam does work in the turbine and then enters a condenser in highly vacuum state, where it condenses into water. In a back pressure steam turbine, the exhaust steam pressure is higher than atmospheric pressure, and exhaust steam is directly used for heating without a condenser. In a regulating extraction steam turbine, a certain pressure of steam is extracted at a certain stage of the turbine for external heating, while the remaining steam does work in the turbine and then enters the condenser. Based on heating requirements, there are distinctions between single-stage regulating extraction and double-stage regulating extraction. In an intermediate reheat steam turbine, the steam expands and does work within the turbine until it reaches a certain pressure, at which point it is completely extracted and sent back to the boiler's reheater for further heating. The reheated steam is then returned to the turbine to continue expanding and doing work. Third, according to the main steam pressure classification, steam turbines can be categorized as low-pressure steam turbines, main steam pressure less than 1.5 megapascal, medium pressure steam turbines, main steam pressure between 2 and 4 megapascal, high pressure steam turbines, main steam pressure between 6 and 10 megapascal. Ultra high pressure steam turbines main steam pressure between 12 and 14 megapascal. Subcritical pressure steam turbines main steam pressure between 16 and 18 megapascal. Supercritical pressure steam turbines main steam pressure greater than 22.2 megapascal. It's worth recalling the concept of the critical point of water steam that we learned earlier. For ultra supercritical pressure steam turbines, the main steam pressure is greater than 25 megapascal, and the temperature is greater than 580 degrees Celsius. We often use axial flow turbines. Let's take a look at turbine models from the turbine model. We can basically judge 4 according to the direction of steam inside the turbine can be divided into axial flow turbine and float flow turbine. Axial flow turbine, the overall direction of steam flow is roughly parallel to the axis, while the flow turbine, the overall direction of steam flow is perpendicular to the axis. The main features of the turbine, everyone needs to be able to understand the meaning is model. Domestic turbine models mostly contain 3 parts of information. The first part of information is represented by Chinese pinyin symbols, indicating the thermal characteristics or purpose of the turbine. For example, here N represents condensing type, B represents back pressure type, CB represents extraction back pressure type, and the numbers following this indicate the rated power of the turbine in megawatts. The second part of information is represented by several groups of numbers separated by slashes, indicating the main steam parameters, reheat steam parameters, coheat steam parameters, etc. Finally, it is the design sequence number. For example, this group of turbine models N30016.7538. It indicates a condensing turbine with intermediate reheat with a rated power of 300 megawatts, main steam pressure of 16.7 megapascals, and both main steam and reheat steam temperatures at 538 degrees Celsius. Now let's look at this model. It represents a double extraction regulating turbine with a power of 25 megawatts, main steam pressure of 8.83 megapascals, first extraction regulating steam pressure of 0.98 megapascals, second extraction regulating steam pressure of 0.118 megapascals. As for turbine models from abroad, they are represented differently. For example, the Russian K80023.55 in the first turbine model, K represents a condensing turbine, 500 indicates a rated power of 800 megawatts. 23.5 indicates a main steam pressure of 23.5 megapascals. 5 is a modified design sequence. The French Alstom TRA 33030 RF 1044. In this model, T represents turbine, R indicates secondary superheating. A indicates symmetrical arrangement, 330 indicates a rated power of 330 megawatts. 30 indicates a speed of 3000 revolutions per minute. RF indicates double exhaust. 1044 indicates the length of the last stage blaze. Everyone should be able to understand the meaning conveyed by the model number of a steam turbine. That concludes the content of today's lesson, classmates. Today we have learned about the development history, types, and models, as well as the working principles of steam turbines. In next class, we will introduce the structure of the steam turbine itself. Please make sure to review and preview in a timely manner.